So we're about to make a really important point about volatility of a portfolio. First thing, we're going to set up an assumption. We're going to make an assumption that all of the assets in the portfolio, that their returns don't move perfectly together in the same direction by the same relative amount. Again, that just means that, they don't move exactly together or proportionally together. And that's reasonable, it's realistic. Even if you had two, let's say, stocks of the same industry, Ford and General Motors or Coke and Pepsi, they might move in similar fashions because they respond similarly to the same economic forces. There's going to be differences between them, even if they're incredibly slight. That's all we need for this assumption. So this is an assumption we're going to make, that when we talk about a portfolio, that the assets don't move exactly together. If that's the case, then there are what we can categorize as diversification benefits, where the standard deviation of the portfolio returns. So we actually look at the returns of the portfolio and measure them and come up with the standard deviation. Then that's actually less than the value weighted average of the standard deviations of the different assets in the portfolio. So you can think about it this way: is we have a bunch of assets in our portfolio. We figure out their standard deviation. We take a weighted average and we come up with some number. And then we look at how the returns of the portfolio actually move around and compute the standard deviation based on, find the mean, find the deviations from the mean, compute the standard deviation. You'll get some number that's less than that. That's important. When we dealt with expected returns, we took a weighted average of expected returns, and that was the expected return of the portfolio. When we dealt with returns, we took a weighted average of the returns of the individual members of the portfolio, and that was the return of the portfolio. If we took a weighted average of the standard deviation of the individual members of the portfolio, we'll get a number, but that number is higher than the standard deviation of the portfolio. Really important. Let's look at why. So again, here's an example. It's set up to be extreme to really clarify the point, to make it clear. So here we have stock A, and hopefully you can see it has a relatively high variance. You can see it's down, it's up, it's down, it's up a little more, it's way down. That day it's down, but not as much. It's down, it's up. It bounces around quite a bit, and we could figure out standard deviation for A. Look at B. B is also a relatively volatile stock. It's up, it's down, it's up, it's down again, it's up, but not by as much. It's up by a little, it's down. We could compute the variance of B and come up with a relatively high number. So you've got A and B, and they're both bouncing around. Well, what happens if we create a portfolio that's half in A and half in B? Take $100, 50, or you have a portfolio that's worth 100, your A is worth 50, your B is worth 50. Take a look at this. You've got A bouncing around, you've got B bouncing around, but what happens to the portfolio? The portfolio returns are actually quite smooth. And the reason is because the returns of A and B tend to cancel each other out. You can see on days when A down here is, negative 9%, B is at plus 10%, plus 6%, minus 5%. So there's some cancellation. So even though RA and RB are quite large, if we actually look at our standard deviation of A and the standard deviation of B are quite large, the standard deviation of the portfolio is relatively small. So again, the example that we just went over, it's extreme, but it highlights what's going on. That as long as the assets have returns that do not move perfectly together, same direction, same magnitude, same relative amount, then the portfolio returns will be less volatile. The standard deviation of the portfolio will be less than the weighted average of the volatilities of the individual assets, the weighted average of the standard deviation of the individual assets. And that's what we just saw in the picture. Again, where does this come from? That's something we'll talk about later in the course, this diversification benefit. But it's important at this stage to see and understand that it comes from this, basically this cancellation, that A and B in this case are both quite volatile, jumping around, and we put them together. There was a tremendous amount of smoothing. You don't need to have such an extreme example to get the basic finding that the weighted average will give you some number that's way up here when the actual volatility of the portfolio is something less than that. So we have a typical asset where the asset returns do not move perfectly together in the same direction by the same relative amount. Then these two we've talked about. The portfolio return is equal to the weighted average of the returns. So what is the return of stock A, stock B, stock C, stock D? What's our holdings of those? Take a weighted average, figure it out. That's the return of the portfolio. Same thing with expected returns. Take a value weighted average of the expected returns for stock A, stock B, asset C, asset D, asset E. That's the expected return of the portfolio. It's important, you can see I'll draw you an exclamation point, to recognize that the standard deviation of the returns is less than the value weighted average. You figure out this value weighted average, and all the stocks individually are bouncing around by a certain amount. Yet when you put them together, there's this diversification benefit, this smoothing out, such that the standard deviation of the actual return, or of the returns of the portfolio, is less than the weighted average of the standard deviations of the individual assets.